Imagine a future so distant that every star you can see in the night sky is gone. The sun is gone. The Milky Way is gone. Every galaxy that fills the observable universe today has changed beyond recognition. The brilliant cosmos we know has faded into darkness. No new stars are being born. No planets remain warm enough for life. No civilizations illuminate the void. The universe has entered an age unlike anything we can imagine, yet something still survives. Black holes, ancient remnants of dead stars, and collapsed galaxies. Invisible giants that have endured for unimaginable stretches of time. For trillions upon trillions of years, they continue to exist while almost everything else disappears. But even black holes are not eternal. One day, the final black hole in the universe will die. And when it does, the last chapter of cosmic history may begin. This is the story of the last black hole in the universe. Chapter 1. Born from death. To understand the final black hole, we first need to understand where black holes come from. Their story begins with stars. Stars are among the most important objects in the universe. They create light. They create heat. They forge the chemical elements that make planets and life possible. Everything around us can trace its origins back to stars. The calcium in your bones, the oxygen you breathe, the iron in your blood, all of it was created inside stars that died long before the Earth existed. Yet stars do not live forever. For millions or billions of years, gravity and nuclear fusion remain locked in a delicate balance. Gravity pulls inward. Fusion pushes outward. As long as these forces remain equal, a star survives. But eventually, the fuel begins to run out. The star can no longer produce enough energy to support itself. Gravity starts winning. The core collapses. Temperatures soar. Pressure rises to extraordinary levels, and for the most massive stars in the universe, the result is one of the most violent events in existence, a supernova. For a brief moment, a dying star can outshine an entire galaxy. An explosion, so powerful that it sends shockwaves across light years of space. The outer layers are blasted away, the core collapses further, and if enough mass remains, something remarkable happens. Gravity overwhelms every known force in nature. The collapse becomes unstoppable. Matter is compressed beyond anything found elsewhere in the universe. The object becomes smaller, denser, more extreme, until eventually a boundary forms, a point of no return. The event horizon. At that moment, a black hole is born. The newborn black hole may contain only a few times the mass of the Sun. Yet all of that mass is compressed into a region astonishingly small compared to the original star. Its gravity becomes so intense that even light cannot escape. This is why black holes appear black. Not because they are empty, because they are holes, but because their gravity traps everything that comes too close. For billions of years, astronomers believed such objects might exist. Then observations began revealing evidence that they were real. Stars were seen orbiting invisible companions. Gas clouds disappeared into unseen objects. Entire galaxies appeared to contain enormous dark masses at their centers. One by one, the clues accumulated. Black holes were no longer theoretical. They were everywhere. And the more scientists discovered, the stranger the picture became. Some black holes formed from dying stars. Others became millions or even billions of times more massive than the Sun. These giants settled in the hearts of galaxies, including our own. At the center of the Milky Way lies Sagittarius A, a supermassive black hole containing roughly 4 million times the mass of the Sun. For billions of years, it has silently shaped the evolution of our galaxy. Yet even Sagittarius A is tiny compared to some of the monsters found elsewhere in the universe. There are black holes so massive that they challenge our understanding of how such objects can form. Ton 618 is one example. This cosmic giant contains tens of billions of solar masses. If placed in our solar system, its event horizon would extend far beyond the orbit of Neptune. These objects represent some of the largest structures ever created by nature. And despite their enormous differences in size, All black holes share one remarkable characteristic: longevity. Stars eventually die, planets are destroyed, galaxies collide and transform, but black holes persist, for timescales so vast that human history becomes insignificant by comparison. A civilization may last thousands of years. A star may survive billions. A black hole can endure for durations that stretch far beyond ordinary imagination, and because of that, they will play a central role in the future of the universe. Long after the last stars fade from the sky, long after galaxies stop creating new suns, long after nearly every familiar object disappears, black holes will remain, waiting in the darkness, silent witnesses to the slow death of the cosmos. But before they become the final survivors, something extraordinary must happen. The stars themselves must die. And that begins the next chapter of our story. Chapter 2. The death of the stars. For most of human history, the stars appeared eternal. Ancient civilizations watched the same constellations rise and fall across the sky. Generations lived and died beneath their light. Empires rose, empires collapsed. Yet the stars remained, unchanging, or so it seemed. But stars are not eternal. They are living objects, with beginnings, lifetimes, and endings. And one day, every single star in the universe will die. To understand how the final black hole emerges, we must travel far into the future, far beyond human civilization, far beyond Earth, far beyond the lifetime of the sun. Imagine accelerating through time. Thousands of years pass in seconds, then millions, then billions. The continents of Earth drift across the planet. Mountains rise and erode. Species evolve and disappear. The sun slowly grows brighter. Eventually, Earth becomes too hot for complex life. The oceans evaporate. The atmosphere changes. The world becomes unrecognizable. Yet this is only the beginning. Billions of years later, the sun enters its final stage. Hydrogen fuel in its core is exhausted. The balance between gravity and fusion collapses. The sun expands into a red giant. Its outer layers swell outward. Mercury disappears. Venus disappears. Earth may follow. The planet that once gave rise to humanity is either consumed or left as a scorched remnant orbiting a dying star. Eventually, the sun sheds its outer layers into space. A glowing shell of gas expands outward. The center remains a white dwarf, a stellar corpse roughly the size of Earth. And no longer producing energy. And no longer shining through fusion, slowly cooling over trillions of years. This fate awaits most stars in the universe, but red dwarfs live much longer, far longer. These small stars burn fuel so efficiently that many will survive for trillions of years. In fact, the universe is not yet old enough for a single red dwarf to have reached the end of its life. Naturally, every red dwarf that has ever formed still exists, but eventually, even they begin to fade. Trillions of years pass, then tens of trillions, then hundreds of trillions. One by one, the last stars exhaust their fuel. The brilliant age of starlight comes to an end. No new stars are born. The giant clouds of gas that once filled galaxies have long since been consumed. The universe enters a new era. An era of darkness. Imagine looking up at the night sky during this distant future. There are no bright constellations, no glowing nebula and no spiral galaxies. The universe has become a far darker place. Only stellar remnants remain. White dwarfs, neutron stars, black holes, the ancient ruins of a once luminous cosmos. Yet gravity continues its work. Even after the stars are gone, objects continue orbiting one another, galaxies continue evolving, and black holes continue growing. Over unimaginable stretches of time, random encounters become important. Stars pass near black holes. White dwarfs are captured. Neutron stars collide. Everything becomes part of a slow cosmic dance, a dance that unfolds over periods so vast that ordinary numbers lose their meaning. Some objects are ejected from galaxies entirely, others spiral inward. Eventually, many find their way into black holes. The black holes feed, slowly increasing in mass, slowly becoming the dominant structures of the future universe. This era is known as the degenerate era, a time when normal stars have vanished, a time when stellar remnants rule the cosmos for trillions upon trillions of years. This strange universe continues evolving. White dwarfs cool into black dwarfs, neutron stars grow colder, planets wander through interstellar darkness, entire solar systems dissolve, the cosmos becomes quieter with every passing age, and still, black holes remain, patient, silent, waiting. The longer time passes, the more obvious their dominance becomes. Nearly everything else is disappearing, yet they endure. Some black holes continue merging with others, creating larger and larger monsters. The giants at the centers of galaxies become even more massive. Across the universe, gravity slowly consolidates matter into fewer and fewer objects. As if the cosmos itself is simplifying, reducing countless structures into a handful of survivors, and among those survivors, black holes reign supreme. If an observer could exist during this distant epoch, they would witness a universe almost impossible to recognize. Gone are the colorful galaxies, gone are the shining stars, gone are the worlds where life once flourished. Instead, darkness stretches across unimaginable distances, broken only by the occasional interaction between ancient remnants. It is a lonely universe, a cold universe, yet it is not empty, because the age of black holes is only beginning. In the trillions of years ahead, these invisible giants will become the most important objects in existence. They will outlive stars, outlive galaxies, outlive nearly everything the universe has ever created, and eventually, they will inherit the cosmos itself. But even then, their story is not finished, because hidden within the laws of quantum physics lies a discovery that changes everything, a discovery that reveals an astonishing truth. Even black holes can die, and that realization will transform the future of the universe forever. Chapter 3. The Age of Black Holes. There was once a time when stars ruled the universe. Their light illuminated galaxies, their energy shaped worlds, their gravity guided the evolution of cosmic structures across billions of years. But that era is over. The stars are gone, the galaxies have faded, and the universe has entered a new age, the age of black holes. Imagine standing in this distant future, not billions of years from now, trillions, but quadrillions and quintillions of years into cosmic history. The universe is almost unrecognizable. The brilliant Milky Way no longer exists as we know it. Long ago, it collided with Andromeda. The two galaxies merged into a gigantic elliptical system. For a time, the collision triggered bursts of star formation. New stars briefly illuminated the darkness, but eventually those stars died as well. Now only remnants remain. The sky is black, not because there is nothing there, but because almost everything that once emitted light has vanished. Across the universe, the dominant objects are black holes. Some were born from massive stars, others formed through countless mergers over unimaginable stretches of time. Many have grown into giants, supermassive black holes containing billions of solar masses drift through the ruins of ancient galaxies. Gravity continues to shape the cosmos. Even now, black holes pull on one another. Their orbits slowly evolve. Occasionally, two encounter each other. At first, they circle from enormous distances. Then, gravity begins drawing them together. Their orbital speeds increase. Spacetime itself starts to ripple. Invisible waves spread outward at the speed of light. Gravitational waves, the final echo of a cosmic collision. As the black holes spiral closer, the process accelerates. Faster, 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 until finally they collide. For a brief moment, an astonishing amount of energy is released, not as light, not as heat, but as distortions in the fabric of reality itself. Then silence returns. One larger black hole remains, another merger complete, another giant born. This process repeats again and again across the future universe. Small black holes become larger ones. Large black holes become monsters. Monsters become titans. The total number of black holes decreases, but their average size grows slowly. The universe consolidates its remaining matter into fewer and fewer structures. It is a process that unfolds over timescales so vast that entire civilizations could rise and fall billions of times without noticing any change, and yet, eventually, the results become undeniable. Black holes become the dominant form of organized matter in existence. Imagine a universe populated by only a handful of enormous gravitational giants, each separated by unimaginable distances, each drifting through darkness older than stars themselves. The cosmos has become quiet, almost perfectly quiet. No stellar explosions. No glowing nebula. No shining galaxies. Only black holes, ancient survivors of a long-dead universe. If this sounds like the end of the story, it isn't, because hidden beneath this apparent permanence lies a secret. For centuries, scientists believed black holes would last forever. The logic seemed simple. Nothing escapes a black hole, not matter, not radiation, not even light. If black holes only absorb energy, they should continue existing indefinitely, eternal monuments to gravity. But in the 1970s, one physicist discovered something extraordinary, something that completely changed our understanding of black holes. His name was Stephen Hawking, and his discovery revealed that black holes are not eternal after all. According to quantum mechanics, empty space is not truly empty. Even the vacuum of space is alive with activity. Tiny quantum fluctuations constantly appear and disappear. Particles emerge from nothingness, then vanish again, almost instantly. This strange process happens everywhere in the universe, even near black holes and near an event horizon. Something remarkable can occur. A pair of virtual particles appears. Normally, they annihilate each other immediately, but if one falls into the black hole while the other escapes, the situation changes. To an outside observer, it appears as though the black hole is emitting radiation, very slowly, very weakly, but continuously. This phenomenon became known as Hawking radiation. It was one of the most revolutionary discoveries in modern physics, because it implied something astonishing. Black holes lose energy, and if they lose energy, they lose mass, and if they lose mass, they eventually disappear. The implications were enormous. For the first time, scientists realized that black holes are more not today, not tomorrow, not even within trillions of years, but eventually. Every black hole has an expiration date. The larger the black hole, the longer it survives. A stellar black hole may last for approximately 10 years. A supermassive black hole can survive for 10 years or more. These numbers are so enormous that they are difficult to comprehend. The entire history of human civilization occupies only a tiny fraction of a second compared to such durations. Yet even these giants cannot escape their fate forever. Over unimaginable ages, Hawking radiation slowly drains away their mass. At first, the process is almost imperceptible. The black hole barely changes. Millions of years pass. Nothing happens. Billions pass. Still nothing. Trillions pass. The black hole remains. But the process never stops. Tiny amounts of energy continue escaping, patiently, relentless, like a cosmic clock counting down toward the end. And eventually, after periods of time beyond ordinary imagination, the age of black holes begins to change. The giants that once seemed immortal start approaching their final moments. The universe is preparing for its next chapter. A chapter unlike anything that came before, because for the first time since black holes were born, they are beginning to die, and one day, only a single black hole will remain, the last black hole in the universe, the final survivor of cosmic history. Chapter 4. The slow death of giants. For most of cosmic history, black holes appear immortal, stars explode, galaxies collide, entire eras of the universe come and go, yet black holes remain silent, unchanging, patient. If an observer could somehow survive for trillions upon trillions of years, they might begin to believe that black holes truly are eternal, but they would be wrong, because deep within the quantum fabric of reality, a slow process is taking place. A process so gradual that entire galaxies could vanish before its effects become noticeable. The process is Hawking radiation, and it is quietly killing every black hole in existence. At first, the change is impossible to detect. A black hole with the mass of a star loses only an unimaginably tiny amount of energy. Its mass decreases by a fraction so small that even over billions of years, nothing seems different. The black hole remains exactly where it was, dark, silent, invisible. But time is no longer measured in billions of years. The age of black holes exists on a completely different scale. Millions of trillions of years pass. The universe continues expanding. Distances between surviving objects grow larger. The remnants of ancient galaxies drift farther apart. The cosmos becomes cold, darker, emptier, and still. Hawking radiation continues, never stopping, never slowing down. Each escaping particle carries away a tiny amount of mass. Each particle brings the black hole one step closer to its end. For the largest black holes, the countdown is almost unimaginably long. Consider a supermassive black hole containing billions of solar masses. These giants may survive for around 10 years, a number so large that it hardly feels real. If every star in the observable universe represented a year, it would still not come close to describing such a timescale. Human language was never designed to handle numbers like these, yet eventually, even these cosmic monsters begin to change. Slowly, their mass decreases, the event horizon shrinks, the giant that once dominated an entire galaxy becomes slightly smaller, then smaller still. The process remains almost imperceptible for most of its life. But as the black hole loses mass, something unexpected happens. It becomes hotter. This is one of the strangest properties of black holes. Most objects cool down as they lose energy. Black holes do the opposite. The smaller they become, the hotter they get. The hotter they get, the faster they evaporate, and the faster they evaporate, the quicker they lose mass. A feedback loop begins. The end approaches. Imagine watching a supermassive black hole during its final stages. For nearly all of cosmic history, it has been a silent giant. Then gradually, the evaporation accelerates. The black hole radiates more energy. The event horizon contracts faster. The countdown speeds up. Millions of years pass, then thousands, then centuries. Eventually, the giant enters its final moments. The black hole that once outweighed billions of stars has been reduced to something far smaller, far hotter, far more energetic. Its radiation intensifies dramatically. The process that once took trillions upon trillions of years now unfolds rapidly. The giant is dying, and then it happens, the final burst. The remaining mass converts into energy. A flash erupts. For an instant, the black hole releases the last remnants of its existence into the universe. Then it is gone. Forever. No event horizon. No singularity. No black hole. Only energy spreading into the darkness. One giant has fallen, but many still remain. Across the universe, other black holes continue their long decline. One after another, they reach the same fate. The stellar black holes vanish. The intermediate giants disappear. The supermassive monsters evaporate. The population of black holes steadily decreases. As the ages pass, the universe grows emptier than ever before. Entire regions of space contain almost nothing. No stars. No planets. No galaxies. Only isolated black holes separated by unimaginable distances. Then even those begin disappearing. The age that once belonged to black holes is slowly ending. The rulers of the cosmos are dying, and eventually, after durations so vast that all previous history seems insignificant, only a few survivors remain. Then a few become one. The mergers are over. The feeding has ended. The growth has stopped. There is only a single black hole left. One final object drifting through an almost empty universe. The last black hole. The final survivor of everything that came before. It has outlived stars. It has outlived galaxies. It has outlived civilizations. It has outlived nearly every structure the universe ever created. For an incomprehensible span of time, it remains alone, the sole monument to a universe that once blazed with light. But even this final survivor cannot escape its destiny. The same law that destroyed every black hole before it now acts upon the last one. Hawking radiation continues, patiently, relentlessly. The countdown has entered its final stage. The universe is approaching a moment that has never happened before. A moment when there will be no black holes left at all. The final chapter of their story is about to begin, and with it comes one of the most haunting questions in all of cosmology. What happens after the last black hole dies? Chapter 5. The Last Black Hole. At last, the universe reaches a moment unlike any that came before. Every star is gone. Every galaxy has faded into obscurity. Every black hole except one has vanished. The universe is older than anything a human mind can truly comprehend. The great eras of cosmic history are over. The stelliferous era, the age of stars, gone. The degenerate era, the age of stellar remnants, gone. The age of black holes, nearly gone. Only a single object remains, one final black hole, the last black hole in the universe. Imagine standing somehow within this distant future. There are no constellations overhead. No galaxies illuminating the darkness. No brilliant quasars. No supernova. No planets reflecting starlight. The sky is black beyond description. Not the darkness of a moonless night. Not the darkness of deep space. A deeper darkness. A universe where almost every source of light has ceased to exist. And drifting through this eternal night is the final survivor. The last black hole. It is impossible to know exactly how massive it would be. Over unimaginable spans of time, countless mergers may have occurred. Perhaps it contains the mass of trillions of stars. Perhaps even more. All that remains of countless galaxies may now reside within this single object. A cosmic graveyard compressed into one final remnant. Every star that ever exploded. Every galaxy that ever merged. Every black hole that ever existed. Their histories have converged into this lone survivor. For a time, it appears eternal. Nothing remains to challenge it. Nothing remains to feed it. Nothing remains to orbit it. The universe belongs entirely to the last black hole. Yet appearances can be deceiving, because Hawking radiation never stopped. Even now, even here. In the emptiest future imaginable, quantum physics continues its silent work. Tiny particles emerge near the event horizon. Energy escapes. Mass is lost. The black hole shrinks. Slowly, almost imperceptibly. But the process continues. A billion years pass. Then a trillion. Then numbers so large that ordinary language becomes useless. Still, the black hole evaporates. The universe has become so empty that there may be no observer left to witness this process. No civilization. No intelligence. No life. The cosmos drifts through darkness alone, yet the final black hole continues moving toward its fate. The irony is profound. This object has survived longer than galaxies, longer than stars, longer than nearly every structure ever created, yet it cannot survive forever. Nothing can. As the final black hole loses mass, its temperature rises, its radiation grows stronger, the evaporation accelerates, the countdown enters its last phase. For most of its existence, the process was unimaginably slow. Now, it begins to speed up. The giant shrinks, faster, and faster, and faster still. The event horizon contracts, energy pours into the surrounding darkness. The final survivor is dying, and then comes the moment that has been approaching since the birth of the universe itself. The last black hole reaches the end. Its remaining mass converts into energy. A tremendous burst erupts into the darkness. The final flash, the last great release of energy in cosmic history. For an instant, after ages of silence, the universe shines once more. Not with the light of stars, not with the glow of galaxies, but with the death cry of the final black hole. Then the flash fades, the energy disperses, the darkness returns, and for the first time since black holes were born, there are no black holes left in existence. The age of black holes has ended. The final giant is gone. The last survivor has fallen. The universe has crossed another threshold. A threshold from which there is no return. No stars remain. No galaxies remain. No black holes remain. The cosmos has become something entirely different. A place unlike anything that existed before. A place where the great structures of the universe are now only memories written into the fabric of spacetime, if memories can even exist at all. Yet, the story is not over, because the death of the final black hole raises a terrifying question. What happens next? What does a universe without stars, without galaxies, and without black holes actually look like? Has cosmic history finally come to an end? Or is something even stranger waiting beyond the darkness? The answer may be the most mysterious chapter of all, because after the last black hole dies, the future becomes almost impossible to predict. Chapter 6. After the last black hole, final black hole is gone, the last great survivor of cosmic history has disappeared. For the first time since the earliest epochs of the universe, no black holes exist anywhere. No stars. No galaxies. No planets. No nebulae. No light. Only an expanding universe filled with extreme darkness. If a conscious observer could somehow exist at this moment, they would witness a cosmos almost impossible to describe. Space stretches endlessly in every direction. The distances between remaining particles are unimaginably vast. The temperature of the universe has fallen to nearly absolute zero. There are no recognizable structures left. No galaxies to navigate by. No stars to illuminate the darkness. The universe has become a nearly featureless ocean of emptiness. This is the heat death of the universe, a future predicted by many cosmological models, a state in which nearly all usable energy has been exhausted. Nothing large remains. Nothing organized remains. Everything that once gave the cosmos structure has faded away. For billions of years, life depended on differences. Differences in temperature, differences in pressure, differences in energy. These differences powered stars. They powered planets. They powered civilizations. But now, those differences are gone. The universe has reached equilibrium, a cosmic stillness unlike anything that existed before. At first glance, this appears to be the ultimate ending, the final chapter, the point beyond which nothing interesting can ever happen again. But physics has a habit of surprising us, because even in an almost empty universe, strange things may still occur. The culprit is quantum mechanics, the same theory that helped explain Hawking radiation, the same theory that governs the microscopic fabric of reality. According to quantum physics, empty space is never truly empty. Even a perfect vacuum contains fluctuations, tiny bursts of activity, brief appearances of particles, momentary disturbances in the quantum fields that fill the cosmos. Most of these fluctuations are insignificant. They appear, they disappear. The universe barely notices them. But given enough time, extraordinary events become possible. And the future universe contains more time than we can imagine. Far more. Imagine waiting not for billions of years, not for trillions, but for numbers so vast that all previous cosmic history becomes insignificant. In such immense spans of time, even events with absurdly tiny probabilities may eventually occur. Some physicists have proposed a bizarre possibility: the spontaneous appearance of self-aware observers, known as Boltzmann brains. The idea sounds like science fiction, yet it emerges naturally from certain interpretations of thermodynamics and quantum mechanics. If random fluctuations continue forever, then eventually particles could accidentally arrange themselves into complex structures, perhaps a brain, complete with memories, thoughts, consciousness, a fleeting observer born from randomness itself. For an instant, it may believe it has a history, a civilization, a universe. Then it vanishes. The concept remains controversial. Many physicists dislike the idea, yet its existence demonstrates how strange the future universe may become. And stranger possibilities still await, because the vacuum of space itself may not be stable. At present, physicists do not know whether the vacuum state of our universe is truly the lowest possible energy configuration. It may be, or it may not. If it isn't, then reality itself could be sitting in a temporary state, a false vacuum, stable for billions of years, perhaps trillions, but not forever. One day, quantum event could trigger a transition to a lower energy state, a vacuum decay event. If that happened, a bubble of new physics would begin expanding outward at the speed of light. Inside the bubble, the laws of nature could be completely different. Atoms might not exist, stars might never form, matter itself could become impossible. The expanding bubble would erase everything in its path, and because it moves at light speed, no warning would ever arrive. The universe would simply change, instantly, fundamentally, forever. Fortunately, there is no evidence that such an event is imminent. It may never happen at all, but the possibility remains one of the most unsettling ideas in modern physics, and even this may not represent the end. Some cosmological theories suggest that entirely new universes could emerge through quantum fluctuations. Perhaps reality undergoes endless cycles: birth, evolution, death, rebirth. Perhaps our universe is only one chapter in a far larger story, a single bubble in an infinite cosmic ocean. Or perhaps countless universes already exist, each with different laws, different histories, different futures. The truth remains unknown, and that uncertainty becomes profound after the last black hole dies, because beyond that point, observation becomes almost impossible. The familiar universe is gone. Only theory remains, only mathematics, only speculation. The cosmos has entered territory no civilization can ever witness directly, and yet, one final mystery still remains, a mystery even larger than the fate of stars, larger than the fate of black holes, larger than the fate of the universe itself. Why does anything exist at all? Why is there a universe capable of producing stars, galaxies, and conscious observers? Why are there laws of physics instead of nothing? These questions remain unanswered. They may remain unanswered forever, yet the journey toward them has revealed something extraordinary. From the birth of stars to the death of black holes, from galaxies to quantum fluctuations, from the beginning of time to the edge of eternity, the universe has proven itself far stranger than anyone once imagined, and perhaps its greatest secrets still lie ahead, waiting beyond horizons we have not yet crossed, waiting in the darkness beyond the final black hole. Chapter 7. The meaning of the final black hole. The last black hole is gone. The stars are gone. The galaxies are gone. The universe that once blazed with unimaginable light has faded into silence. And yet, somehow, the story feels incomplete, because throughout this journey, the final black hole was never really the point. It was only the destination. The real story was everything that led there. Think about what the universe accomplished before reaching this distant future. From a cloud of hot plasma left behind by the Big Bang emerged galaxies. Within those galaxies, stars ignited. Inside those stars, heavier elements were forged: carbon, oxygen, iron, the ingredients necessary for planets. the ingredients necessary for life. Over billions of years, worlds formed around countless suns. Some remained barren, some were destroyed, and perhaps, on a few rare worlds, something extraordinary happened. Matter became aware of itself, life emerged, intelligence followed. Civilizations rose beneath alien skies. Creatures looked upward and wondered about the stars. Perhaps they built telescopes. Perhaps they asked the same questions we ask today. Where did the universe come from? How will it end? Are we alone? What are black holes? Across billions of galaxies and trillions of worlds, countless minds may have asked these same questions. Most of them are gone now. Their stars have died. Their planets have vanished. Their civilizations have become dust. Yet, for a brief moment, they existed. And that may be more important than it seems, because the universe is not merely a collection of particles and forces. It is also a story that unfolded over nearly 14 billion years, a story that transformed simple hydrogen into stars, stars into planets, planets into observers. For a tiny fraction of cosmic history, the universe gained the ability to look back upon itself. Through conscious beings, through curiosity, through science, and perhaps that is one of the most remarkable events in existence. Consider our own species. Humanity appeared only moments ago on the cosmic timescale. If the entire history of the universe were compressed into a single calendar year, modern civilization would occupy only the final seconds before midnight on December 31 Street. Yet during that brief instant, we achieved something extraordinary. We learned that Earth is not the center of the universe. We discovered galaxies beyond our own. We measured the age of the cosmos. We detected planets orbiting distant stars. We photographed the shadow of a black hole. We observed gravitational waves created by colliding black holes billions of light years away. And we began asking questions about events that will occur trillions upon trillions of years in the future. Questions about the final black hole. Questions about the ultimate fate of reality itself. That achievement is astonishing. Species living on a small rocky planet around an ordinary star managed to uncover secrets written across the universe. Not because we were the strongest creatures, not because we were the fastest, but because we were curious. Curiosity is one of the most powerful forces in nature. It drives exploration. It drives discovery. It drives understanding. Without curiosity, the stars would simply be lights in the sky. Black holes would remain invisible mysteries. The universe would remain silent. Instead, curiosity transformed ignorance into knowledge, and every answer led to new questions. The more we learned, the larger the universe became. The more mysteries we solved, the more mysteries appeared. Black holes are a perfect example. Once thought impossible, then theoretical, then discovered. Now, they stand at the center of some of the deepest questions in physics. Questions about gravity. Questions about quantum mechanics. Questions about information. Questions about the nature of space and time themselves. Even today, black holes continue challenging our understanding of reality. And perhaps they always will, because every generation reaches the edge of knowledge, then pushes beyond it. The final black hole reminds us that knowledge itself is a journey without a true ending. There will always be another horizon, another mystery, another question waiting in the darkness. Even if humanity survives for millions of years, even if future civilizations spread across the galaxy, even if they unlock secrets we cannot yet imagine, the universe will remain larger than our understanding, and perhaps that is exactly what makes it beautiful. Not that it can be fully explained, but that it continues inspiring wonder. The final black hole may represent the end of cosmic structure, the end of stars, the end of galaxies, the end of familiar history, but it does not represent the end of meaning, because meaning was never stored inside stars, or planets, or black holes. Meaning emerged through those who observed them, through those who asked questions, through those who sought understanding, and as long as curiosity exists somewhere in the cosmos, the story continues. even in the face of cosmic endings, even in the shadow of black holes, even at the edge of eternity, the universe remains an invitation to explore, to discover, to wonder, and perhaps that invitation is the greatest gift the cosmos has ever offered, because long before the final black hole dies, and long after our own lives have ended, the questions will remain, waiting for the next observer, waiting for the next discovery, waiting beneath the stars. Epilogue: the universe after us. For most of human history, people believed the universe revolved around them. Ancient civilizations looked at the stars and imagined they were lights placed in the sky for a purpose. The heavens seemed eternal, unchanging, perfect. But science revealed something far more extraordinary. The universe is not static. It evolves. Stars are born, stars die, galaxies collide, black holes grow, entire cosmic eras come and go. Everything changes. Even the grandest structures in existence are temporary. The final black hole is proof of that. If something as powerful as a black hole cannot survive forever, then permanence may simply not exist in our universe. And yet, there is something strangely comforting about that realization, because it means we are part of the same story. The same laws that govern galaxies govern us. The atoms inside our bodies were forged in stars. The iron in our blood was created in stellar explosions billions of years ago. We are not separate from the universe. We are one of its creations, a product of cosmic evolution, a consequence of countless events stretching back to the beginning of time. Every breath you take contains atoms older than Earth, older than the sun. Some may have traveled through multiple stars before becoming part of you. In a very real sense, every person is connected to the history of the cosmos. We are made from ancient starlight, and perhaps that is why the night sky has always fascinated us. When we look into space, we are looking at our origins. The story that made our existence possible, a story written across billions of years, a story that eventually leads to black holes. Galaxies. The fate of the universe itself. But there is another reason these questions matter. They remind us of scale. Human problems often feel enormous. A difficult year, a failed plan, a setback, a disappointment. Yet compared to cosmic history, even entire civilizations are brief moments. Empires rise and vanish. Languages appear and disappear. Generations come and go. The universe continues. This perspective does not make human life less meaningful. It makes it more precious. Because our time is limited, stars do not shine forever. Planets do not last forever. Neither do we. The rarity of existence is what gives it value. And the fact that conscious beings can exist at all may be one of the most remarkable events in cosmic history. Think about the odds. For billions of years, the universe contained nothing but particles, radiation, and darkness. Then stars formed, planets formed, life emerged. Eventually, somewhere on a small world orbiting an ordinary star, a species began asking questions about black holes, questions about time, questions about the future, questions about existence itself. That species was us. And despite all our limitations, we learned to see beyond our world. We built telescopes capable of looking billions of years into the past. We developed mathematics capable of describing invisible objects. We discovered black holes long before we ever photographed one. We detected ripples in spacetime itself. We learned to read the history of the universe. Few achievements are more extraordinary, because the universe did not owe us those answers. Every discovery required curiosity, patience, persistence, generation after generation, building upon the work of those who came before, and the journey is far from over. Today, we still do not know what lies inside a black hole. We do not know whether information can truly be destroyed. We do not know whether other universes exist. We do not know how the universe began, and we do not know how it will ultimately end. those mysteries remain, waiting, just beyond the edge of current knowledge, the same way black holes once waited beyond the limits of ancient science. One day, future generations may solve questions that seem impossible today. They may understand quantum gravity, they may discover entirely new laws of nature, they may unlock secrets hidden within space-time itself, or they may uncover mysteries even stranger than anything we can currently imagine, because history has shown that reality is always more surprising than our expectations. Every major discovery has expanded the universe, not physically, but intellectually. Every answer revealed a deeper question. Every horizon exposed another horizon beyond it, and perhaps that process never truly ends. Perhaps knowledge itself is infinite data, an endless journey through an endless cosmos. If so, then the final black hole is not merely a story about endings. It is also a story about exploration, about curiosity, about the desire to understand. The last black hole may one day disappear. The stars may fade, the galaxies may vanish, even the universe itself may change beyond recognition, but the search for understanding is what gives meaning to our place within it. Because for a brief moment in cosmic history, the universe became aware of itself through living minds, through questions, through wonder, through us. And maybe that is enough. Maybe that is the greatest miracle of all, that in a universe destined for darkness, there was once light, that in a universe governed by physics, there was once curiosity, that in a universe filled with silence, there were beings who asked questions, and among those questions was one simple thought: what happens to the last black hole in the universe? Now, we know the answer. It dies. Like stars, like galaxies, like everything else, yet its story leaves behind something far more valuable than permanence: perspective, wonder, and a reminder that no matter how much we discover, the universe will always remain larger than our imagination. Thank you for joining this journey across the deepest reaches of time and space, from the birth of stars to the death of the final black hole, from the beginning of the universe to the edge of eternity. If you enjoyed this exploration, be sure to like the video, subscribe to the channel, and turn on notifications so you don't miss future journeys into the greatest mysteries of the cosmos. Your support helps us continue creating documentaries that explore the wonders of space, science, and the universe. And before you go, let us know in the comments, if you could witness any moment in the future of the universe, what would you choose to see? The collision of galaxies? The birth of a new universe? Or the final flash of the last black hole? Thank you for watching. Stay curious, keep exploring, and never stop looking up at the stars, because somewhere beyond the next discovery, beyond the next horizon, beyond the next mystery, the universe is still waiting to be understood, and our journey has only just begun.